Morning. Assalamualaikum. Last class we had stopped at Gauss elimination. Okay, just to recap. For the Gauss elimination, okay, using the example that we had done, you need to convert the bottom triangle into zero. Okay, you need to zero the bottom triangle. This part need to be zero. So how we zero the part is by using pivoting method. Okay, we pivot the first row so that to eliminate the x1. Okay, so then by finding the factor, you will need to use the factor for the whole row. Okay, let's say row 2 over here. Yeah. Okay, row 2. We need to zero this 3. Negative 3. So we pivot row 1, then finding the new equation so that this 3 will be 0. We cannot simply negative 3 plus 3. It will be 0. But we need to find the factor. What does it make the value to be 3? So the factor is from pivoting row. Okay, by using the pivoting row R11, which is this one, as your base, denominator for the factor. Okay, so from there, you will get 0. That's how you get 0. Now, same goes for row 3, the set using the factor. Okay, you need to find the factor, how to zero this 5. Okay, then once you zero the 5, you need to zero this part as well, 2.75. So that's when you pivot the second row. Okay, you pivot the second row so that the 2.75, negative 2.75 will be 0 as well. You need to find the new factor. Each time you pivot a row, there will be a factor. So you need to find out that factor, the one that can zero this bottom 3. Okay, how to know your answer is correct? By substituting back into the main equation, either one of the main equation, or by using calculator. Okay, sometimes using calculator, you will get syntax error. It will delay your time. So it is advisable just to go substitute into the equation. Any equation would be correct. Let's say you choose equation 3. So substitute back your x1, x2, x3. If you get 9, then your answer is correct. Okay? Okay, that is Gauss elimination. We want to zero the bottom triangle. Now I move to LU decomposition. LU decomposition basically similar to Gauss elimination. Okay, in linear algebraic, we have Gauss, direct elimination, and iterative. Gauss and LU is using matrix. Jacobi and Gauss-Seidel is iterative. So I will finish up the matrix one first. Then only we will go to the iterative. As what I think this one is for civil student. They are covering the same syllabus. Okay, after we are done with LU, then we will go to Jacobi as well. Now for LU, LU stands for lower and upper decomposition. Decomposition here means from the given equation, you must decompose the matrix into lower and upper bound. Okay, so upper bound, this part should be 0. This approach similar to Gauss elimination. You need to zero the bottom triangle by finding what are the factors that can zero the thing, zero this part. Okay, then once you get the factor, for example, let's say, for example, R121, R21 minus, let's say, just for example, 1/3. So R11. So this is the factor to find the new row, to zero row 2 by pivoting the first row. Okay, let's say this is your factor. So for the L matrix, this factor is the one that you will put into here. This XX value is the value of your factor, the one that you zeros the bottom triangle. Okay, so this factor, later on you will have 3 factors. So those 3 factors will be substituted into the lower bound matrix. Okay, we try to do example so that you understand further. Meaning that this LU is an advanced method from the Gauss elimination. If Gauss, we stop up to upper bound. LU, we have a lower bound over here. Okay. Let's say this is the question. Example, this is the question. Given the 3 equations, then it asks you to find out x1, x2, x3 using LU method. Okay. So from the given example, from the given equation, first step is to decompose the matrix into lower and upper bound. Okay, concept of LU is this. This one you need to memorize. This one will not be given in the assessment. Okay, concept of LU is A multiplied by X equals to B. A here is matrix A multiplied by matrix X equals to matrix B. Okay, so from the equation given here, this is the A, okay? Rearrange them into matrix form. This is matrix A, X, and B. Now the concept of LU, AX equals to B. This is the original version of the matrix. Then UX equals to B. U here is the upper bound matrix, the one that you will find out later. Upper bound matrix multiplied by the X equals to B. Okay, then if UX, okay, UX equals to K, LK equals to B. Now, L here is the lower bound. Equation 1 refers to UX equals to K, LK equals to B refers to equation 2. Okay, from equation 1 over here, you have two unknowns, X and K. You only know matrix U. Okay, that's why later on, once we found out what are the U and the L matrix, we will proceed to equation 2 first to find the K. Once you get the K, then only you go back to equation 1 in order for you to find the X. Okay? Follow me closely. Let me know if I go too fast or you want me to stop. Now we need to find lower bound and upper bound. Okay, this is the original matrix, matrix A. First, to find the upper bound, we need to zero the first triangle. As we know, the the bottom triangle. Okay, the bottom triangle. So this part need to be zeros. Similar approach as Gauss elimination. You need to find the factor, how to zero the 64, 144, and 12. Okay, first step, pivot the first row. Now find the new value on R2, row 2. Okay, find the new value on R2. Where R2, this one is the original matrix, minus 64 over the pivot row. Value in the pivot row must be the denominator. Okay, so this is the factor to zero this part. Okay, try to calculate your new R2. Is it you get the same value as mine? Okay, if you get the same, try to zero the 144 over here so that it becomes 0. Then this one is different factor, R prime 3. So the old factor, the old value in row 3 minus the factor. So the factor here will be 144 over 25. Why over 25? Because we are pivoting first row. Oh, sorry, where is it? Okay, so 144 over 25 is your second factor. Factor to be put at the position 3, 1 later on L matrix. Okay, so negative 16.8 here using the same factor. Okay, next part is to zero the negative 16.8. How to zero this? By pivoting the second row. Second row, pivot. So find the new equation for the R double prime 3. What does it mean by R double prime is for this value. Okay, this one remain. Okay, this one remain. So now you need to find the new value for R double prime 3. First, 3, 1, we had zeros. So nothing much to do about this. Next, we must zero the negative 16.8. So find the new equation where the factor over here will be negative 16.8 over negative 4.8. Okay, we are here, the upper bound. So this is your U matrix, the final U matrix. Once you are done with the U matrix, now generate the L matrix. The L matrix, we know that only the bottom triangle has values. Okay, this one is standard. 1. The diagonal one is 1. The top triangle is 0. Diagonal 1, top triangle 0. Now we need the values for the bottom triangle. This value comes from the factor just now. So here, this is your first factor just now. Okay, this is the first factor where you need to find the factor to 0, 2, 1. Okay, over here. Now this part is your second factor. The last x over here is your third factor. Okay, so here is your L matrix. So these two matrices later will be used to determine the x. Up to here, let me know if you have questions. If you are still not and cannot capture the the factor, be aware, it should be in bracket. Here, in bracket. Not the sign minus over here is not considered. You should just take the value inside the bracket. Okay, but for R, the third factor over here just now, you have negative 16.8 over negative 4.8. So consider those signs. Okay. Okay, now moving forward, I move to the next slide. We have our L and U matrix now. Wait, let me make it darker. Yeah, I convert the factor just now into point form to ease my calculation. So it's up to you if you want to remain in the previous form. Okay, this is L matrix, U matrix. Okay, now from equation 2, LK equals to B. equation 2. L, the L matrix over here. Okay, multiply by K matrix. K1, K2, K3. This is your unknown. B, the known value in the first place just now. B is from the given equation, this one. Okay, so this is your B. Why we proceed with equation 2 first? Because in equation 2 has only one unknown, which is the K. Now find out what is those K's. From here, from the first row, we can form into the equation where K1 equals to 106.8. So from here, you can calculate your K1 equals to 106.8. This is your K1. Using the K1 value, calculate your K2. Okay, to find your K2, 2.56 K1 plus K2 equals to 177.2. K1, you already have the values. So find out your K2. K2, you should be getting these numbers. Okay, try to find your K3. What do you get for K3? K3, 16. Could be 0.76. Okay, once you get the case, now move to equation 1, where Ux equals to K. So U, we have find out just now, matrix U Now we want to find the x's. Okay, by plugging in your k value just now. Sorry. Okay, let me know what is your x1, x2, and x3. K3. Try to calculate again, you should get 0.76. You get 0.76 or 7? 7.61. Sabah, you get what? No, I mean the K3, sorry, K3. 0.76, right? Try check back your calculation. Okay, I think typo here. This one should be 1. 1. The diagonal should be 1. So 5.7 K1 plus 3.5 K2 plus K3 equals to 279. So your X, Sabah, what you get? X 1.85, okay. X2 20.4 or 0.4? Sorry, I read it wrong way. X3 1.086, X2, X1 0 point x1. Mine is 0.22. So this one is the one that you different, right? 20.4. X2. Try to calculate again. You get the correct value? Oh, yeah. Yeah. Into the equation, whether you can get the answer. Oh, Petong, just now x1 you get what? 0.29. 0. Okay, your answer might be different, might differ a little bit from the answers over here. As long as it is in the range. Okay, because sometimes it depends to the decimal point that you take from the beginning of your calculation. Okay, if you are done, try this exercise. Wait, let me make it visible. Sorry. Find the axis using LU method. Okay, so identify what is your L and U matrix. From matrix A, decompose into matrix L and matrix U. Find what are the factors to zeros the bottom triangle of U, then plug in the factors into the L matrix. I share with you the answers for the K and the X's. You can try to validate using the calculator as well. You will get the same answer. Okay, last question. This one from previous midterm. Okay, from our exercise just now, the equation has been given to you. The three equation has been given to you. So you just directly use it, decompose it, and find the factor. Okay. Now let's say if the question gives you something like this. It only gives you the value in table form. Wait, let me make it bigger. Okay, the table shows the viscosity of solution. Viscosity of solution produced using three materials with different mass, with different masses. Okay, so M here is the mass. Here is the viscosity. Okay, it asks you to find the unknown masses, M1, M2, M3. So this is the unknowns. These are your unknowns. As in exercise previously, this one are the excess, okay, the unknown. Using LU method with the coefficient of mass given in three formulations. Okay, so here it gives you in three formulation. M's are your unknowns. Okay, so you have to generate your equation, or you can straight away generate the matrix. Okay, so let's generate the equation first. Okay, so to be similar approach as our exercise previous. Okay, now here, first formulation, 16M1 plus 9M2 plus 10M3 equals 5.5. Okay, so this is the equation that you need to generate. So same goes to the second formulation. You generate the thing, the equation. Okay, so these are the equations. Now, how about the matrix? You need to identify what are the matrices. A, unknowns, and your B. Okay, so your A matrix, this is your A matrix. Then your unknowns. Then this is your B matrix. Okay, similar approach. A similar step as the exercise. Try to find the unknowns using LU method. Okay, so those are the M's value. So just to let you know, for the midterm, I will cover up to this topic. For chapter 3 will be covered by Gauss elimination or LU, either one. Okay, so chapter 1, the roots, chapter 1 will be the error, and then the roots, open method, bracket method, then the matrix, chapter 3. Okay, so midterm will be covered up to chapter 3 until LU. Okay, Jacobi, the rest, because since we haven't done yet, I will not cover for the midterm. Okay. Okay, a gentle reminder, midterm will be on this Friday, 11 a.m. at C405. Okay, so that's all for today. I have captured the attendance. Thank you.